meeting, supplied by Yingze Huang. His presentation is titled Heatwave-mediated decrease in phytoplankton quality negatively affect zooplankton productivity. Let's welcome graduates.
Good afternoon, everyone. My name is Lin Jiaju, and I'll be presenting today. My topic is heatwave-mediated decrease in phytoplankton's quality negatively affects zooplankton's productivities, published on Functional Ecology 38, and my third advisor is Professor Heatwave. First, let me introduce the main character of the study, phytoplankton. Phytoplankton are crucial for the aquatic ecosystem. They are the primary source of nitrogen, carbon, phosphorus, and essential fatty acids in the aquatic ecosystem. They form the foundation of the entire food web and the ecosystem, acting as a keystone species that maintain ecological balance. Most importantly, phytoplankton serve as the main producer of N3 polyunsaturated fatty acid, what we commonly know as omega-3 fatty acid. And these are the vital for the growth and the productivity of higher level tropical organisms. However, in recent years, global temperatures rise caused by climate change has become a major concern. Rising global temperatures has significantly affected the distribution, morphology, and the chemical composition of the aquatic organism. Among these impacts, the effects on phytoplankton are particularly concerning. The dangers brought by climate change are limited to continuously rising air and water temperature. The frequency of extreme weather events has also clearly increased, and that's the main reason why the author choose heatwave as their main focus. Speaking of heatwave, we need to know the definition of a heatwave. According to the Intergovernmental Panel on Climate Change, IPCC, they defined heatwave as 5 consecutive days with maximum temperatures exceeding the climate baseline for the same date by at least 5 degrees Celsius. The author was wondering, is there any differences between the heatwave and constant warming affect the phytoplankton? The authors believe that when phytoplankton face a short but extreme heat stress, it could cause decrease in their nutritional value, then affect the entire food web. This affects not only phytoplankton themselves, but also the animals that eat them. The author based their study on 3 main hypotheses. First is the temperature-dependent physiology hypothesis and RNA efficiency hypothesis. The authors believe that when temperatures are high, it could cause decrease in nitrogen and phosphorus concentration within phytoplankton. This happens because when temperatures rise, phytoplankton could grow faster. When they do, they will need less RNA. And since RNA contains a lot of nitrogen and phosphorus, which leads to a total nutritional level to decrease. Second is homeoviscous adaptation hypothesis. The authors believe that when temperatures rise, phytoplankton cell membrane stability could go down. And in order to maintain the membrane stability, the cells need to increase the proportion of monounsaturated fatty acid, MUFA, and the saturated fatty acid, SFA, which leads to decrease in polyunsaturated fatty acids, PUFA. Last is the N3 to N6 fatty acids ratio. The authors consider N3 to N6 ratio as an indicator of nutritional quality. When temperatures are high, the ratios could go down, which means that the food quality was bad. Follow-up will be the experimental method. The study was conducted at the research pound of University of British Columbia. They collect samples from ponds which is not involved in any experiment. They collect samples on phytoplankton, zooplankton, and water sample. They use tool is a 64 micrometer plankton towel net and handheld aquarium net. And there's phytoplankton and zooplankton. For the phytoplankton, in order to cultivate enough phytoplankton, the collection began 3 weeks before the experiment started. For the zooplankton, the sample will go through another 64 micrometer screen to remove larger substance like invertebrate to make sure that sample's purity. For the zooplankton rearing, field collected zooplankton will be brought into the laboratory, thoroughly mixed, and evenly distributed to 27 plastic food-grade buckets. Each container will be filled with 6 liters of filtered pond water. The filtering removes substances like zinc, mercury, lead, acetose, ibuprofen, and chlorine. And for the phytoplankton, phytoplankton will be put into 3 different temperatures regime. Each temperature regime have 9 replicates. Use a 3.8 liter glass jar and filled with 3 liters of wild-caught phytoplankton and top it with filtering pond water. Like I just said, phytoplankton will be put into 3 different temperatures regime, which were the ambient treatment, constant warming, and the heat wave. And the temperature setting of the ambient treatment will be 20 degrees Celsius at day and 16 degrees Celsius at night, simulating local summer average temperature. And for the constant warming, the temperatures will be 24 degrees Celsius at day and 20 degrees Celsius at night, which was 4 degrees Celsius above the average. And last, the heat wave. Heat wave have a unique temperature pattern. It starts same as the ambient treatment and gradually went to the temperature's peak and then gradually went down. The temperatures of the peak was 34 degrees Celsius at day and 52 degrees Celsius at night. The temperatures was actually based on the 2021 Vancouver summer record high temperatures, which was 32.4 degrees Celsius. In order to prove that constant warming and heat wave have a different effect on phytoplankton, the author used degree days calculation to measure the total heat accumulation in both groups. This is to make sure that both groups receive equal amounts of heat and remove heat as a variable factor. The study shows that these 2 groups has a similar degree day, which was 8.17 versus 8.58. And for the feeding strategy, each phytoplankton replicate will be paired with 1 zooplankton replicate. It's easy for author to track down which phytoplankton was fed to which zooplankton. And the feeding amount was based on counting the amount of phytoplankton using an automated cell counter. This is to make sure that zooplankton have enough phytoplanktons to eat, but not too much, because leftover food could make the water dirty or even harm the experiment. And in order to make sure that phytoplankton won't grow in the zooplankton's container, zooplankton will be kept in low light condition. And during the entire experiment, there will not be any water's replacement. Only 300 millimeters of filtered pond water added to the container weekly during the feeding. And on the data collection, I'll explain what and when the authors do during the entire experiment. First, like I just said, the collection of phytoplankton starts 3 weeks before the experiment started in order to cultivate enough phytoplankton. And starting from day 1, they will have the first sampling. And also on day 1, the temperature treatment started too, from day 1 to day 52. And the next sampling day was on day 22. And the last sampling day was on day 51. And then what they do with the samples? The author collects data on phytoplankton's elemental concentration, fatty acids concentration, biomass, and general diversity. For the zooplankton, the collection began 5 days before the experiment started, a total 11 days until day 6. And on day 6, the feeding experiment also started. started from day 6 to day 52, the feeding was 3 times per week. And the next sampling day was on day 22, and the last sampling day was on day 52. We have noticed that the end dates of these two are actually different. And that's the reason why is that the author didn't have enough time to process and analyze all the samples on the same date. And on the zooplanktons analyzed, the author analyzed biomass, growth rate, Shannon diversity, and fatty acids concentration. Most interesting is that the author was wondering, is there any connections between the zooplankton's biomass and phytoplankton trait, which were the elemental concentration and the fatty acids concentration. What will be the result? First, what happened to zooplankton after each special temperature-treated phytoplankton? What we see here on the biomass is that the Heatwave group had clearly the lower on biomass compared with other two groups. However, on the growth rate and Shannon diversity, it shows no significant differences between these three groups. And on the phytoplankton's elemental concentration, what we see here is that the Heatwave group clearly had the lower of all the elementals concentration. Follow-up will be the phytoplankton fatty acids concentration. I have highlighted SFA and MUFA with a red box, which means that the higher level of these two are bad. What we're seeing here is the calcium warming group clearly had the higher SFA compared with other two groups. And our MUFA also, calcium warming group still had the highest compared with other two groups, and there is a significant differences. And for the PUFA and N3 to N6 ratio, I've highlighted with the green box, which means that the higher level of these two are good. What we see here first, on the ambient treatment, it have higher PUFA compared with the Heatwave group. There is differences, but not very significantly. However, what we see here on the calcium warming group, on PUFA it had the highest. It's weird, right? Because the highest is the good. However, we need to take N3 to N6 ratio into consideration. What we see here on the MB group is that it had highest of N3 to N6 ratio. Compared with other two groups, there is a significant differences. For the big questions, what happened to zooplankton fatty acids concentration? Also, I have highlighted SFA and MUFA with the red box. What we see here is that the Heatwave group clearly had the highest on SFA. But on MUFA, the calcium warming group had the highest. For PUFA, on the ambient treatment, is have the highest compared with other two groups. Compared with calcium warming and Heatwave on PUFA, there is a differences, but not very significantly. That's most importantly the N3 to N6 ratio. On the ambient group, we see here is the highest compared with other two groups, and there is a significant differences. A small summary from here is that calcium warming and Heatwave do have a negative effect on phytoplankton that affect zooplankton, but they are through a different mechanism. Follow will be the phytoplankton biomass and Shannon diversity changes across the entire experiment. First, let's look at the biomass. At the start and the middle of the experiment, the study shows there is no significant differences between these three groups. However, at the end of the experiment, the calcium warming group clearly had the lowest. On the Shannon diversity, the study shows that temperature's treatment have no significant effect on Shannon diversity across the entire experiment. But what we see here is that the Shannon diversity went down over time. This suggests that one phytoplankton species could become dominant and others die off. Last, the relationships between zooplankton's biomass and phytoplankton's trait. The x-axis is the phytoplankton trait. We look on carbon, nitrogen, phosphorus, three different fatty acids, SFA, MUFA, PUFA, and the last, the N3 to N6 ratio. And the y-axis is the phytoplankton's biomass. The finding here is that these three nutrition, carbon, nitrogen, and MUFA, have a positive relationship to the zooplankton's biomass. In other words, the changes of these three nutrition in phytoplankton could have affect the zooplankton's biomass. A quick summarize. On the heat wave group, it shows that zooplankton's biomass and important elementals concentration has decreased. Most importantly, the N3 to N6 ratio went down. And on the constant warming group, it shows that phytoplankton and zooplankton to have more of the bad fatty acid and less of the good fatty acid. Most importantly, the N3 to N6 ratio went down too. Overall, the authors successfully proved that heat wave has a significantly negative effect on phytoplankton than affect zooplankton. On the constant warming part, it shows there is a similar negative effect, but through a different mechanism. This study gave us an important insight into how climate change could affect our aquatic ecosystem in the future. However, what we see here from the study is that any temperature increase could affect the quality of this tiny organism. This shows us something important, that climate change isn't just about hotter weather or rising temperatures. It affects our planet in ways we not even notice at first. Think about it like a butterfly effect. A small changes in these microscopic creatures could eventually become a bigger problem that we couldn't fix later. This gave us both an opportunity and a warning. Climate change and global warming are happening right now, but we still have time to do about it. What we have to do is take this problem seriously and act on it. And that's the end of my presentation. Thank you.
Thank you, Andrew, for your presentation. Now we'll move on to the Q&A session. If anyone has questions, please feel free to raise your hand.
我想先问说，这一篇是探讨说气候变迁影响那个浮游生物的那个研究嘛？那我是想问说，这一篇研究它对于那种海洋保育的，作者有提到说，它对于那种海洋环境保育的那个工作有什么实质性的贡献吗？
针对这个部分的话，作者并没有做一个太多的回应，因为这个研究主要是以从海洋环境的最底层的这些生物的小的影响，而进而可能会影响到整个未来宏观的海洋环境，所以对于这部分可能没有太多的说明。
我只是想说，就是会不会是说，它对于那种保育。就是那种海洋保育会有那种有实质性的那种研究贡献之类的，就是可以。
我认为这个还是有很大的贡献，只是可能没有像就是这个要提到海洋保护的话，有啦，就是提倡这个部分是非常重要的议题。
我想问一下 IPCC 的议题。就是除了这个，就是你讲的这个指标以外，还有其他的组织提过类似的东西吗？就是类似像Heatwave这种指标。
这部分我不知道，但我认为这应该还是一个非常有指标性的指标，这就是为什么做中法放在这里。
我想问就是，你说热浪会影响到phytoplankton的品质嘛，然后进而影响到zooplankton。那它 响到其他生物，就是其他吃phytoplankton的动物，什么鱼啊之类的。
这个部分的话，可能没有到非常的确定这件事情，但是是可能会影响。毕竟这个就是从最底层的影响空间，可能会对我们更大的环境会有更大的影响。所以确实是非常没有讲，但是我认为是非常有。
I want to ask if there be any difference if this experiment was conducted in wild.
That's an excellent question. That the paper actually talk about is there any differences if the study was conducted at wild? It's a great chance is that there have a difference over different results. It's also the author have to mention that it's a little flaws that it didn't have to have done a outdoor experiment.
那我想的话，还有考虑到就是还是什么，这个我想想想。
你说针对海水成分的改变，还有什么？
就是这些会不会影响到一些？
哦，你是说针对于温度对于海水成分的改变，会不会进一步影响到 phytoplankton 的一些部分吗？这部分它虽然没有明确的讲。但是呢，我觉得应该还是有一定程度的改变。
可以解释一下浮游生物的生物面意义。
好，那这个部分是我刚刚可能没有讲到多的，就是文章中有特别把那个结果部分有特别把 zooplankton 的 biomass 跟 phytoplankton 的 biomass 提出来，而这个部分呢，是因为可能会有人会觉得说，zooplankton 的 biomass 在 Heatwave 这个组别，它变低流，会不会就是单纯就是因为可能会有食物供量不足这个部分？那我们回来看这个 phytoplankton 的生物量的部分，我这边可以看到，就是它跟 ambitrimum 比起来啊，在 biomass 的情况下是没有太大差异。然而在 constant warming 这个部分确实有变低，所以我们就可以直接的把 biomass 这个部分的 biomass 会不会影响到 zooplankton biomass 的这个问题移除掉，就不会是它像文中提到的，可能是有食物供应不足的问题这样子。
我想问，为什么作者有量那个浮游植物的盐分含量，然后呢量浮游动物？
针对这个问题呢，为什么作者只有量浮游植物的元素含量，但没有量浮游动物的元素含量？那是因为在实验的最后，作者没有足够的 sample 再去做这个部分的实验，所以他就决定不做。
我想问，就是这个实验啊，是这个热量会对生物在营养层面上有直接的影响？
那这部分呢，实际上也是个非常好的问题，就是这个实验主要还是以间接的方式可能会探讨可能会的影响这样子。它影响了 phytoplankton 的品质，然后才会影响到 zooplankton 的生产的 productivity。所以这个部分的话，不是一个直接的关系，这反而是一个间接的关系。这个在文中也有提到，这是他们未来会想要去探讨的。如果把 zooplankton 一样放在这个 Heatwave 跟 constant warming 的情况下，会不会有一些不一样的结果？
可以解释一下那个 Shannon Index 的结果，就是在整个research里面的意义。
这个部分吗？还是说它的意义是什么？
对，就除了它是那个多样性，就是物种的多样性变化，就是随着时间变化以外，就是这一个结果。
这个结果部分的话，除了展现它的多样性以外，更重要的点就是就是在这个环境下，我放在不同的温度，不同的温度组别，或者为了不同的温度组别的 phytoplankton， 它对于这整体的多样性会有太大改变。如果它放在 Heatwave 组别特别糟糕， 代表说他们采集到的这些 phytoplankton 是不是就不能在这种情况下生长出来，或者是说可能会有另一个其他的问题，那我是不是就没有办法单单的讨论说以 phytoplankton 的品质会不会直接影响，反而会要引发出很多其他部分的问题。
Alright, if there are no more questions, let's thank Judge for his great talk.
Okay, curious about how about Heatwave oscillation. I mean, because Heatwave is very short term, right?
Yes.
And maybe only 5 days. But in experiment, yeah, they also able try to maybe 5 days high temperature and maybe cool down for maybe 1 day and maybe 1 week, and then another heating again. Because oscillation means that because I think in Heatwave they always have this one. Yeah, maybe this week very hot and then not, and then hot again. I think this is more real condition. So I don't know if this experiment can reflect, this condition.
I think it's a very great point of view, but I couldn't make a firm opinion about how when it happened, when the temperatures could go up and down, like what happened in the real world. But I think with a short term of these experiments, it actually could have a small reflection of the real world, but not very determined on the results.
Maybe move to the next slide. The experiment design time. This one. So the warm is totally how many days for warm treatment?
Oh, the temperatures treatment start from day 1 to day 52.
Okay, totally around 2 months. Okay, so how about Heatwave? Yes.
Also, the temperatures treatment are the same date. A total of the exact date of the temperatures treatment is on this. From day 1 to day 52.
Okay. So actually Heatwave only maybe
10 days.
10 days. So maybe I can explain maybe one sample heating for only 10 days and another one sustained for 50 days.
Oh,
Right? So we just want to see a difference. We also just to see any difference between short-term heating or long-term heating, right? So maybe not Heatwave. Yeah, just because I think Heatwave should be defined more clear in this study.